You know how your favorite apps sometimes feel like they can read your mind? Well, that's not magic. Not really. It's machine learning. And in the next few minutes, we're going to pull back the curtain on the key models that power pretty much everything in our digital world. So let's get into it.
So let's start with this one simple question. What if a computer didn't need us to write code for every single tiny little task? What if it could just learn from experience, from data, the same way we do? That right there, that's the big idea we're about to explore. And here it is, the textbook definition. At its core, machine learning is all about teaching computers to spot patterns by just showing them a ton of data. It's a huge shift, right? We're moving away from telling a computer exactly what to do, and instead we're showing it examples and letting it figure out how to do the job on its own. Now, this whole field isn't just one giant thing. It's actually split into two major approaches, almost like two different philosophies on how a machine can learn something new. And this slide lays out that big difference perfectly. On one side, you have supervised learning. Think of it like a student who has both the textbook and the answer key. The model learns from data that's already been labeled with the right answers. And on the other side, that's unsupervised learning. Here, the model just gets a bunch of raw data and has to figure out the patterns and groups all by itself. No answer key. So let's dig into that first camp, supervised learning. The name really says it all. The whole learning process is supervised because we're giving it these labeled examples to learn from. Here's a super simple way to picture it. Imagine you feed a model thousands and thousands of data points. Each one links a person's age to their shoe size. The model starts to see the relationship between these two things. And pretty soon you can give it a new age it's never seen before, and it can make a really good guess, a prediction about the shoe size. That's it. That's learning from labeled inputs and outputs. Okay, but even inside supervised learning, there are two main jobs a model can do. The first is called regression. That's when you want to predict a number on a scale, like the price of a house or tomorrow's temperature. The second is classification. This is when you want to put something into a box or a category, like deciding if an email is spam or not spam. So let's dive a little deeper, starting with regression. Remember, this is all about forecasting a specific number. And you've got a whole toolbox for this. Linear regression is the classic. It's just about finding the best straight line to fit your data. But then you have more complex stuff like decision trees, random forests, and of course neural networks, which are kind of modeled after our own brains to find some incredibly complex patterns. Let's just zoom in on the random forest for a second because it's a really cool idea. Instead of just relying on one decision tree, which could easily be wrong, it builds a whole forest of them. Each tree sees the data a little differently. Then, to make a prediction, all the trees vote. It's like the wisdom of the crowd, you know? Asking 100 experts is way more reliable than just asking one. All right, let's talk about the other side of the supervised coin, classification. With this, our goal isn't a number, it's a label. We're trying to assign something to a category. And here is where things get really efficient. You don't always have to reinvent the wheel for a new task. Those same powerful models we just saw, decision trees, random forests, neural networks, they can do classification too. The logic inside is pretty much the same. They're just tweaked a bit so that their final answer is a category, like cat or dog, instead of a number, like 42. And, of course, there are other specialized tools. Logistic regression is fantastic for those simple yes or no questions. A support vector machine, or SVM, is like an expert at drawing the best possible line to separate different groups of data. And naive Bayes just plays the odds, using pure probability to figure out where something belongs. Okay, so we've covered what happens when you have the answer key. Now let's jump over to the other camp, unsupervised learning. This is where the machine has to figure things out on its own. So with unsupervised learning, you basically just give the model a mountain of data, but no labels, no right answers, nothing. Its entire job is to just explore all that data and tell you what's interesting. It has to find the hidden structures and the natural groupings all by itself. And this whole process usually boils down to two main jobs. The first is clustering, which is all about finding similar things and grouping them together. The second is dimensionality reduction, which is just a fancy way of saying simplify the data by getting rid of stuff that isn't important. And the power of clustering is incredible. It literally brings order to chaos. You can give it a massive, messy data set, and it will automatically organize it into these meaningful groups, showing you structures you might never have noticed on your own. And you see this everywhere. Companies use it to group their customers for targeted marketing. That's customer segmentation. Banks use it to spot weird patterns in transactions that could be fraud. It can even take thousands of documents and automatically sort them by topic. It's pretty amazing. And finally, we have dimensionality reduction. I know, it sounds super technical, but the idea is actually pretty simple. Imagine your data has hundreds of different features or variables. It's just noisy and slow to work with. This process, using techniques like PCA, intelligently boils all that data down to just its most essential parts. This makes everything faster and makes it way easier to find the real signal.
Okay, we just flew through a whole bunch of models and techniques. So after all of that, what's the big idea? What's the one thing you should really take away from all of this? Here's the bottom line. Whether we're predicting an outcome with supervised learning or finding a hidden pattern with unsupervised learning, all of these models are just incredibly powerful tools that help us make sense of really complex data. They help us find the signal in the noise in a world that's getting more complicated every single day. And that leaves us with one final thought. From the news you see, to the music that gets recommended, to the ads that follow you around, these models are running behind the scenes. So the next time you're scrolling through your feed, just ask yourself, which one of these models is deciding what I see next?